Hello, and welcome to a video about something called a reactivity series. It's a little bit of chemistry, and it's all about the word reactivity and reactive. Now I could stand here and tell you what does reactive mean, what does reactivity mean, but I think we can work it out from a little bit of common sense. So what I've got here, I've got three metals. I've got some zinc, I've got some aluminium, and I've got some magnesium. Now these all have different levels of reactivity. Now remember, I've not told you what reactivity means yet. In these three test tubes here, I have got some hydrochloric acid, and I am going to put a piece of metal in each one. So I'm going to put some zinc in that one. There it goes. I am going to put some aluminium in the other one, which is closed up. Let's get some of that out there. There's a piece of aluminium. Should have practiced this. Aluminium goes in there, and then I'm going to have a piece of magnesium that goes in there. Now straight away, what can we see here? We can see that the magnesium is very, very fizzy. What is that I've put on there? That is the little piece of aluminium. Is there much going on there? Not too much. And then I had zinc in here, and the zinc is in the bottom there. And there's, I can tell you from here, there are a few little bubbles on the zinc. Some tiny bubbles coming out from the zinc. Very little happening with the aluminium, and the magnesium is going a little bit crazy. So if I was to say to you, of these three metals, which is the most reactive, even though I haven't told you what the word reactive means, you would say, well, the most reactive is the aluminium, because it is reacting faster. And then you have got the zinc, where they've got a few little bubbles coming off, and then aluminium, where you haven't really got much going on there at all. If we came back and had a look after a while, you might see something. So if I was to put those three things in order of reactivity, I would start off with magnesium. Magnesium is very reactive, it's very fizzy. Then the zinc, a few little bubbles coming off of there, and then thirdly, aluminium, like that. Okay, so you've got the idea of what the word reactivity means, or reactive. If something is more reactive, it's more keen to get involved in a chemical reaction. And now we're going to look at what happens when two metals meet each other, and one is more reactive than the other, and one of them's got hold of something that the other one wants. And these are things called displacement reactions. So let me just talk to you about a couple of things here. If we had a metal compound, that's a metal joined with some other elements to make something. For example, let's say copper sulfate. Now copper sulfate is a blue liquid, and it is made from copper, sulfur, and oxygen. So that copper metal has managed to hang on to something called sulfate, which is a mixture of sulfur and oxygen. In fact, if we're going to be really clever, let's write it down. There's one copper, one sulfur, and 4 oxygens on there. Now I can tell you now that copper's not very reactive. It doesn't fizz anywhere near as much as something like magnesium when you put it into some acid. So if I was to get some magnesium and bring that thing along there and put the two together, and you think, what would you expect to happen? Magnesium can see that the copper has managed to hold on to something called sulfate, but the magnesium says, well, you know what, I'm more reactive than you, so I'm going to have that sulfate from you. I'm going to nick it off you. And that is what we call a displacement reaction. If something more reactive, like magnesium, comes along and finds something less reactive, like copper, holding on to something, it will take it away from it. And let's see if I can, yeah, just bear with me a minute. I'll pause and we'll come back. Right, okay, so we're back here again now. So what I've got now is I have got some copper sulfate, which is a nice blue liquid. Now remember, in here, this is a compound, so it's copper joined on with some sulfur and some oxygen to make this nice pale blue liquid. And then the magnesium comes along, and the magnesium is a little jealous of the copper because it doesn't have a sulfate to hang on to. And it sees that and it says, well, do you know what? I'm going to take your sulfate away from you. And the copper says, yeah, all right then, have a go, see how you get on. And you drop that in there, like that. And now, if we can get a little bit closer to that, nice shaky hand, something is actually happening in there. Give it a little bit of a shake up so you can see what's going on. Now you can see some fizzing going on in there. Let's put that in here so it doesn't shake around quite so much. Now there is some fizzing, and there's a little bit of noise coming off there as well. If I get close you might be able to hear it, but there is a displacement reaction going on. And what's happening there is that the magnesium's come along, it's met some copper sulfate, and it says, you know, I'm having that off you. And so the magnesium takes that and it becomes magnesium sulfate, and the copper then gets left on its own. So if we was to leave this, the magnesium would all disappear and there'd be little bits of copper would appear at the bottom here because the magnesium displaces one thing away from the other. And we use this so that we can put metals in order of reactivity. Now I'm going to do another little experiment with 3 little metal compounds and 3 metals and see who can displace which from whom. Okay, so I shall pause this, and when we come back we'll be doing an experiment. Okay, so we are here now at an experiment, and let me show you what we're going to do here. Now these little dimples here are going to take some of the metal compounds. So here is some copper sulfate, which is what I showed you earlier on in the video. So let's just fill up these little dimples with some copper sulfate. So all the ones across here are in copper sulfate. These 3 here, I am going to put some magnesium nitrate into those. So I've got another jar of that and a pipette. So that's magnesium nitrate. Just have to take my word for this one. And so all those 3 dimples there are full of magnesium nitrate. And then in the last row we got at the bottom, we're going to have some iron nitrate. So each of these are what we call metal compounds. So it has a metal, copper, magnesium or iron, and that is joined with nitrate. Well, that's it's nitrogen and oxygen. If it's called a nitrate, if it's a sulfate, it's sulfur and oxygen. And so those metals, copper is managing to hang on to a sulfate here, magnesium's managing to hang on to nitrate, and iron's got its own nitrate there. And then what I'm going to do is I am going to put some of the bare metal in there. So this says copper, so there's a piece of copper I'm just dropping in there, and another piece of copper goes in the magnesium nitrate, a piece of copper goes in the iron nitrate, and then we have 3 pieces of magnesium. Now magnesium goes in the copper sulfate, and we saw that earlier in the test tube. It's not quite in there, it's sorted itself out. Magnesium going in the magnesium nitrate, iron's going in the iron nitrate, and then for iron, I've got some little iron nails here. So popping an iron nail in there, one in there, I'll poke that one in a bit more, and then one goes in the iron goes in the iron nitrate. Now, hopefully you'll have a look at this and think, well, copper and copper sulfate, nothing's going to happen there because it's copper having a fight with itself, so nothing's going on there. Magnesium nitrate and copper, magnesium has managed to hold on to some nitrate. Can the copper come and take the magnesium off it? And if it is doing something like that, you'd see some kind of reaction going on there. See, if you look here, the copper sulfate, copper's hanging on to some sulfate, magnesium comes along and it's taking it away. You can see there's a reaction going on there, and so there's something going on there. What about the copper and the iron? Now if you look at that little nail that's in there, the tip of the iron nail has changed. It's gone like a coppery colour. So the copper sulfate reacts with the magnesium and the iron. So that tells you that magnesium is more reactive than copper because it's stealing its sulfate away. and you're going to have to take my word for it. Maybe it will show up on the video a little bit clearer. But iron is also reacting with copper sulfate. So the iron is coming along and stealing its sulfate away. So that tells me that magnesium and iron are both more reactive than copper. Now you look at the magnesium nitrate. It's not reacting with the copper. So the copper's come along, tried to steal the nitrate, but it's not getting anywhere with that because the magnesium is more reactive, so it cannot displace the nitrate away. Magnesium and magnesium, well, there's nothing going on there because it's fighting itself. And then magnesium and iron. Now that iron nail is stayed shiny, which means the iron has tried to steal the nitrate away from the magnesium, but it can't because the magnesium is more reactive than the iron, so it won't win in a fight. Then we look at iron nitrate. Iron nitrate and copper, there's nothing going on here because the copper is unable to steal the nitrate from the iron because the iron is more reactive than the copper. And we found that before because this iron here stole the sulfate from the copper sulfate here. Iron and magnesium. So there is iron nitrate here. So the iron is hanging on to some nitrate, and then the magnesium comes along. Now, can't see it too well, but there is a reaction happening there. There's a change of colour that's gone on there. You can see it on the other side. The magnesium, just pure magnesium, is a nice silvery colour, but this has changed colour because the magnesium is now winning in the battle with the iron over who gets the nitrate. And then the iron and the iron, nothing obviously happens with those because that's fighting against themselves. So if I was to put these in order of reactivity, the most reactive, number one, is magnesium because it steals from the copper sulfate and it steals from the iron sulfate. The next is the iron, number two, trying to write upside down, not very good. So, and then copper is the least reactive of those three. Now there is a whole massive thing called a reactivity series, which will put something like about 20 different elements in order of reactivity, and you do that by doing similar kinds of experiments to this. So these are displacement reactions to show the relative reactivity of three metals. We often do it with four metals, but three is just easier to show on this screen here. Okay, so magnesium has displaced copper from the copper sulfate, which is why we call it a displacement reaction. So there we go. In this lesson, we have looked at what reactive means, and we have looked at how you can place things in order of reactivity depending on how they get on with metal compounds of other metals and whether they can take things right. Okay, now the next lesson I am going to show you possibly the most spectacular displacement reaction that we do in science, and hopefully that will work out all right. Okay, see you next time. Bye.